We are given an array with positive numbers and a positive target number. We need to find all of its contiguous sub-arrays whose product is less than the target number. Now what is a sub-array? A sub-array is just a part of an array. To solve this problem, we can use a sliding window approach combined with two pointers. Now if you don't know what a sliding window approach is, so it's just an algorithmic pattern just like two pointers. In many problems like where we deal with arrays or you can say linked lists, when we are asked to find or calculate something among all the subarrays or sublists of a given size, we can use a sliding window approach there. We will see how this sliding window approach works. Now we can define a window of subarray. We can define it between the indices pointed by the two pointers left and right. All the elements between the left and right will be called our window. The window starts from the leftmost side of the array, or you can say from the beginning of the array, both left and right at position 0. Okay, so let's take an example. Suppose we have 2, 5, 3, 10 as our input array and k is 30. And let's also initialize our pointers left and right, which initially points to the position 0, or you can say the first element in the array. And we have initially a product of 1. So the left and right points to the position 0, and we have a product of 1. Now, what we need to do, we need to maintain a window of subarrays. A window of subarrays found between the left and right. All the elements between the left and right will be our window. So if let's say if the left is at the first position and the right is at the last position, so all the elements between the left and right are our window. Okay, what we can do with our window, we can expand our window. So to expand our window, we add a new element into the window by incrementing right, and to remove an element from our window, we increment our, and to remove an element from our window, we increment our left. So this 2 will be removed from our window. This is how approach works. So basically we are using it with the two pointers combined with the sliding window. Okay, so how our algorithm is going to work? We need to calculate all our products until our product becomes greater than or equal to 30. We need to add all the elements, or you can say all the subarrays in our new array that will hold all our subarrays that are valid, that have a valid product less than or equal to k. Let's say if our product becomes greater than or equal to 30, then we need to shrink our window. To shrink our window, we remove the first element from our window, and we also increment the left pointer by 1. Our first element in the window is always going to be the left pointer. Okay, so this is how it's going to work. So 2 times 1 becomes 2. So our product is 2 now, and 2 is less than or equal to k. So we add this in our new array. So it's a sub array that is a valid product that is less than k. And we also need to increment our right. We are adding a new element into our window. So our product was 2. So 2 times 5 becomes 10. So 10 is less than the 30. So we also need to add 5 as well. And we also need to add both of these elements as a subarray, which are in range between left and right, as well in our array. This also forms a valid subarray that has a product less than k. And then we increment our right pointer by adding a new element. So to add a new element in our window, we can increment the right. Okay, so now the product was 10. So 10 times 3 becomes 30. So now the product is so now our product becomes greater than or equal to 30. So what we need to do, we need to remove the first element from our window. So remember, the first element is always going to be the left pointer. So it is 1, it is 2. So we need to remove the 2 by incrementing it by 1. This is how we removed it from our window. and we also need to divide the current product by this removed element. The removed element was 2, so 30 by 2 gives us 15, so our product becomes 15. Okay, we keep dividing our product with the removed element until our product becomes less than equal to the target, becomes less than or equal to the target again. Okay, so our product is less than target again. Now it is 15. So we add these elements between so we need to add all these elements in the range between right and left, which is 5 and 3. So first we need to add 3, and then both of these elements, that will also form a valid subarray that has a particular less than k. So we added 5 and 3, so the product was 15. We need to also increment the right. So now our window is this, and now we calculate the product again. So 15 into 10 becomes 150. So 150 is greater than or equal to the target. So what do we need to do? We need to remove the first element from our window by incrementing it by 1, and we also need to remove it, and we also need to divide our current product by the removed element. The removed element was 5, so 150 by 5 gives us 30. So our product is now 30. So still our product is greater than or equal to 30. What we need to do? We need to increment our left, and also need to divide it by the removed element. So 30 by 3 gives us 10. So now the 10 is less than or equal to 30. So this is also a valid subarray that is a product less than k. So this is our output for this input for this example. These are all our valid subarrays that are a product less than k. Okay, so let's code it out. Okay, let's create a resultant array that will hold all our subarray that will have a valid that will have a product less than k, and initially our product is going to be 1. Now we need to traverse through the array inside this loop, and inside this loop we will calculate our product, and if our product becomes greater than or equal to the k, we need to remove the first element from the array, and also need to divide it with the and we also need to divide the product with the removed element, and then we need to store all these subarrays as well inside the resultant array. So to loop through the array using the right pointer, right less than, we run this loop until our becomes less than the length minus 1. So to calculate our product, we need to multiply the product with the num set right. If our product becomes greater than equals to k, we run this loop until our product becomes greater than or equal to k. If it becomes greater than or equal to k, we need to decrement the product by dividing with the removed element, and the removed element is going to be the first element in our current. So we need to divide the product with the removed element, which is num set left, and we also need to increment left as well. Now we create another temporary array that will hold all these subarrays for this current window. Let's call it temp. Now we run a loop. Now we run a loop from right to left, and we need to store all these subarrays for this current window inside our temporary array. You can say for let I is equal to right, and we run this until the I becomes greater than or equal to left, and I minus minus. We need to add this current subarray at the beginning, so we need to to add an element at the beginning of the array, we can use the unshift built-in method on the temporary array. So the element is going to be num set I, and we also need to push this current subarray into our resultant array. We need to push this as an array, we can spread over it, and in the end we need to return our result. Okay, so we need to return the length of the array, not all these sub-arrays. We can do result at length. So we need another condition inside our while loop. The left is still less than the num's length, and also this condition is going to be num's length. Let's run it. Okay, so all our test okay, so all of our test cases are being passed. Let's submit it. Okay, so we are getting a runtime error. This is because if our input is large, so what we are doing, we are storing all our sub-arrays inside this resultant array. So it makes our code break. So what we can do, we can, instead of pushing all the sub-arrays inside a resultant array, we can keep a count variable which keeps the counts of all the sub-arrays that is the product less than k. So instead of doing it this way, we can declare a variable count. And now to calculate we don't need this code now. We just need to calculate the count of the sub-arrays that have product less than k. What we can do, we can say count plus is equal to right minus left plus 1. So all the elements between this current window will give us the counts of such sub-arrays that have a product less than k. So we can return the count. And we need one more condition, and that is if the k is less than equal to 0, we need to return the 0. Okay, so let's submit it now. Okay, we can say the k is less than or equal to 1.